JVM architecture diagram. Here you can see the JVM architecture diagram. A virtual machine is a software implementation of physical machine. Java was developed with the concept of WORA, write once, run anywhere, which runs on a VM. The compiler compiles the Java files into a java.class file. Then that .class file is input into JVM, which loads and executes the class files. As shown in this diagram, JVM is divided into three main subsystems: class loader subsystem, runtime data area, and execution engine. Class loader subsystem. The Java's dynamic class loading functionality is handled by the class loader subsystem. It loads links and initialize the class file when it refers to a class for the first time at runtime, not compile time. Loading classes will be loaded by this component. Bootstrap class loader extension, class loaders, class loader and application class loader are the three class loaders that will help in achieving it. Bootstrap class loader, responsible for loading classes from the Bootstrap class path. Nothing but rt.jav highest priority will be given to this loader. Extension class loader, responsible for loading classes which are inside the ext folder, jre /lib. Application class loader, responsible for loading application level class path mention, environment variables, etc. These class loaders will follow delegation hierarchy algorithm while loading the class files. Linking, verify, bytecode verify will verify whether the generated bytecode is proper or not. If the verification fails, we will get the verification error. Prepare, for all static variables, memory will be allocated and assigned with default values. Resolved, the all symbolic memory references are replaced with the original references from method area. And initialization, this is the final phase of class loading. Here all static variable will be assigned with the original values and the static block will be executed. Runtime data area. The runtime data area is divided into 5 major components. Method area, all the class level data will be stored here, including static variables. There is only one method area per JVM and it is a shared resource. Heap area, all the objects and their corresponding instance variables and arrays will be stored here. These are also one heap area per there is also one heap area per JVM. Since the method and heap areas share memory for multiple threads, the data stored is not thread safe. Stack area, for every thread, a separate runtime stack will be created. For every method call, one entry will be made in the stack memory, which is called stack frame. All local variables will be created in the stack memory. The stack area is thread safe since it is not shared resource. The stack frame is divided into 3 sub entries. Local variable array, related to the method, how many local variables are involved and the corresponding values will be stored here. Operand stack. If any immediate operation is required to perform, operand stack acts as a runtime workspace to perform the operation. Frame data. All symbols corresponding to the method is stored here. In case of any exception, the catch block information will be maintained in the frame data. PC registers. Each thread will have separate PC registers to hold the address of current execution instruction. Once the instruction is executed, the PC register will be updated with the next instruction. Native method stack. Native method stack holds native method information. For every thread, a separate native method stack will be created. Execution engine. The bytecode which is assigned to the runtime data area will be executed by execution engine. The execution engine reads the bytecode and execute it piece by piece. Interpreter. The interpreter interprets the bytecode faster but executes slowly. The disadvantage of the interpreter is that when one method is called multiple times, every time a new interpretation is required. GIT compiler. The GIT compiler neutralizes the disadvantage of the interpreter. The execution engine will be using the help of the interpreter in converting bytecode, but when it finds repeated code, it uses GIT compiler, which compiles the entire bytecode and changes it to a native code. This native code will be used directly for repeated method calls, which improve the performance of the system. Intermediate code generator produces intermediate code. Code optimizer, responsible for optimizing the intermediate code generated above. Target code generator, special responsible for generating machine code for native or native code. Profiler, a special component responsible for finding hotspots, that is whether the method is called multiple times or not. A profile is here. Garbage collector collects and removes unreferenced objects. Garbage collection can be triggered by calling system.gc, but the execution is not guaranteed. Garbage collection of the JVM collects the objects that are created. JNI, Java native interface. JNI will be interacting with the native method libraries and provide native libraries required for execution engine. Native method libraries. This is a collection of native libraries which is required for the execution engine. Here you can see class loader subsystem interact with stack runtime data areas. Runtime data areas interacts with execution engine and native method interface. Class file is connected to class loader subsystem. Loading is connected to linking. Linking is connected to initialization in class loader subsystem. Bootstrap class load is connected to execution class loader. Execution class load is connected to application class loader. Verify is connected to prepare. Prepare is connected to resolve. Method area, heap area, stack area, and PC register and native method stacks are in stack and in runtime data areas. Threads are in stack area. In thread, stack frame, LVA, OS, and PD, FD frame data and are there. PC register for thread 1, PC register for thread 2, and PC register for thread N, and there are in PC registers. interpreter, GIT compiler, and garbage collections are in execution engine. In JIT compiler, intermediate code generator is connected to code optimizer. Code optimizer is connected to target code generator, and profile also in JIT compiler. And execution engine interacts with native method interface. Native method interface interacts with native method library. Now this is the end of my presentation. Thank you very much for watching it.